All right, well, we're back with a bit of a rule that's on steroids. There's two parts, but I'm going to make it 2.5. So this is called the product rule. Now, what that means is that you have something that's multiplied. So if I could look back at yesterday's note, let's see if I can. Oh, no, I didn't save it. If we did look back at the power of a function question, that would be our last example with the equation of the normal and the equation of the tangent. So that could have been done that way, but we were able to foil. So it would look like this question, which is easily, foilable. But I'm going to show you the product rule. The challenge with the product rule is sometimes it sprawls right across the page and maybe even into another line. So we'll give you a tip when that happens. So the deal with the product rule is that you have two chunks of information. So two, not terms, but two expressions or an expression and a term. So here's an expression and a term. Here's two expressions. You have two of them and they're being multiplied together. So that means they're jammed up against each other. That looks like this. And when you find the derivative of the entire thing, you have to take the derivative of the first chunk of information and then you multiply it by, notice the lack of tick here. So you have to multiply it by the original second piece. Then you have a plus sign. So product rule uses a plus sign. Then you take the derivative of the back piece of information and multiply it by the non-derivative, the original of the front. So I've written that here. The derivative of the first multiplied by the original second plus the derivative of the second multiplied by the original first. So I'm going to do that now. Now, I've used f at x for the first question, which says find the derivative. And I am going to do some scribblies off to the side, which some of you might find useful and some of you might find useless. I don't know where to put this thing, so it's just going to hover until I'm out of space for this one. So I'm going to do some stuff in green. So the first thing is, turn my pen around. If I dig out green, the first piece of information is, and even though this is f at x, I'm going to call this f at x. No, I'll call it g. So g at x is equal to 2 plus 7x. And then g prime at x, so the derivative of that, is 0 plus 7, so 7. Then h at x, let's call the second one, which is x minus 3. And if I take the derivative of that, that's 1 minus 0, which is 1. So now I've got all the pieces that I need for this. So, blue pen, f prime at x equals the derivative of the first, so that's the 7, multiplied by the original second, which is the x minus 3, plus the derivative of the second, so that's the 1, multiplied by the original first, which is the 2 plus 7x. And because none of the brackets have exponents, it is worth us multiplying this out and collecting like terms. So this is the easiest kind of question we get when we don't have exponents on the bracket. So multiplying both by 7, multiplying both by 1, collecting like terms, 14x minus 19, and we're done. So I'm not going to write this in. It's all f prime at x. We're done taking the derivative. So now I can work with b, which is actually a little bit bumped up in difficulty, and I may need a couple of lines for this. So this time, over here in green, my f at x is equal to x squared, so that's the first expression. And my f prime at x, so the derivative of that, is 2x to the 1. Then, I could use f at x because y was over here. G at x, the second piece, is 2x plus 4, oh crap, to the exponent 3. That makes it a power. So when I take the derivative of this, I drop the 3, I keep writing, I make it a 2, and then I go inside and I multiply by the derivative of 2x plus 4, which is just 2. And I've got monomials, So 3 times 2 is 6 times the 2x plus 4 to the 2. So now I've got all my pieces that I can go back over here and do the derivative. So I can piece them back together. So the derivative of the front, derivative of the first multiplied by the original second. Derivative of the first multiplied by the original second. Plus the derivative of the second, which we cleaned up here, and that should be a 2. Times multiplied by the original first, which is x squared. So I'm going to make this look nice because here's the plus sign, and this is like our dividing line. So I've got no cleaning up at the front, so I can just leave it. And at the back, behind the monstrous plus sign, I've got a monomial here and a monomial here, so I can combine them to be 6x squared times 2x plus 4 to the 2. Now, we are not done, but the good part is I don't have to write this bracket out 3 times in FOIL, and I don't have to write this bracket out 2 times in FOIL. So that's not the case. Unfortunately, it is worse than the case up above, where I didn't even have any exponents on the brackets, which let me very easily multiply it out and collect like terms. So this time we have to factor. So yeah, factoring happens in calculus quite a bit, and being able to do it properly is a plus. So I have to compare the before the plus sign with the after the plus sign and see what I can take out of both. So we're common factoring. So out of 2x and 6x squared, I can remove a 2x. Out of 2x plus 4 to the 3 and 2x plus 4 to the 2, I can take out the little guy, which is 2x plus 4 to the 2. And then in a square bracket, I can now tell you what's left. So you have to retrace your steps, as in we took 2x out of 2x, so it's not there anymore. We took 2 of these 2x plus 4 brackets out of 3 of them, so if I had a number, I would have to put it in a bracket, but I can just write down one of them here. Big plus sign, not that it matters the size of the plus sign. If I take 2x out of 6x squared, I'm left with 3 and an x, and I took all the brackets out so I can stop, and then I can collect like terms in the square bracket. So that's 5x plus 4. And this is just fine as an answer, but like I mentioned in one of the previous notes, chances are fairly good that the answer ends up looking like this in the back of a book, where this piece is first because it's a monomial, this piece is second because it doesn't have an exponent, and then the 2x plus 4 to the 2 is last. Not that it matters which version you use. All right, so we got some more. And they just keep getting more and more and more complicated. I will have to take a couple of breaks because my hand cramps when I do these questions. So, pulling these out of the way so I have room to scribble and do the question side to side. So luckily I've used a y here. So that means when I go over to the side, I can say that f at x is equal to x plus 1 squared, and now I can take the derivative of it, which unfortunately needs the power of a function rule. So drop the 2, keep writing, make it a 1, go inside, find the derivative of x plus 1, which is 1, and if you want, you can clean it up here. This is not how a textbook will do the question. I will show you in a minute how a textbook would do the question. So the next one is g at x, and g at x is 3x plus 4 to the exponent 3, and the derivative of that is drop the exponent 3, keep writing, make it 1 less, go inside that bracket, ignoring the 3 because you dealt with it. So that's the first level of the Russian doll. The derivative of 3x plus 4 is 3, and I've got two monomials that I can multiply together and make this look a little bit simpler. So now I'm going to take all this information right here, and I'm taking it to the other side where I can actually finish the question. So, blue pen. I'm about to take the real derivative with the pieces off to the side. So the derivative of the front sitting here. So 2 bracket x plus 1 times the plain old back, which is sitting here. Plus sign, big monstrous plus sign. Derivative of the back sitting right here in its cleanest form. Times the front, which is here or here, not the derivative of it, the original, and I get that. So I'm looking at this where there's no monomials to collect, and this which there's no monomials to collect. So I can go straight to my factoring line. So I need to find a number that divides into 2 and 9, and there isn't one, so I skip that. Then, I need to find my x plus 1. So I've got 1 up at the front before the plus sign, and I've got 2 at the back, so I'm only legitimately allowed to take out one of them. There it is. And then I can see that I've got 3x plus 4 as a bracket in the first half and the second half. This one's got 3 of them. This one's got 2 of them. I can only take out 2, the minimum. And then I lay down a square bracket. So now you recompare. So the 2 is missing, so I need the 2. This bracket matches identically in number, so I don't write that down. I've got 1 left because I took 2 of them out of the original 3. So now I have that. Big plus sign. Compare this again to the back half. So I need the 9. And x plus 1, I took 1 bracket out. There used to be 2, so I need another one sitting here. And my 3x plus 4 squared bracket matches exactly, so I can just end that. And now you get to multiply this out and collect like terms. Not this stuff. That stuff's going to stay as it is. I'm going to drop down a little bit, and I'm going to cheat. So this stuff stays the same. And I want to make that square bracket look a little bit nicer. And notice how the square bracket doesn't have any exponents, which tells you you're kind of moving in the right direction. So I'm going to take out the green pen, and I'm going to scribble in here illegally and collect like terms. So this is 6x plus 8 plus 9x plus 9. So multiplying the 2 through, multiplying the positive 9 through. So if I collect like terms on that, I'm left with 15x plus 17, and there's my final answer. I could potentially have these 3 brackets in a different order. There's 6 orders in case you care. And I need the squared on the 3x plus 4 bracket regardless of your order. So now I'm going on with D. And we're going to do the same thing, only I'm going to do it in a way that a textbook would. So I apologize in advance if this throws you off. If it does, you can always resort to this stuff, which I will go back and do for E, but I'm not going to do it for D. I'm going to do it in one big motion for this, and then I'm just going to follow the rules. So I need the derivative of the front. So that is, I'll put like a little lightning bolt down here to tell the difference between the front half and the back half, and the front half contains its exponent. So now I have to drop the 4, keep writing, make it a 3, go inside this bracket, ignoring the 4 because you've dealt with it, and that's 2x plus 0, so 2x. That's the derivative of the front. Now I have to times it by the back. Big plus sign. because I'm done my 2 steps there, even though my front was 2 steps in itself. So now I have to repeat but backwards. So drop the 2, keep writing, make it a 1 if you want to legitimately write that there. Pretend that the 2 doesn't exist because you've dealt with it, and go inside here and multiply, or take the derivative. So that's 2x plus 3. Now it's 2 plus 0. So 2. And then don't forget to write down the front original. So my hand is falling asleep, so I'm going to take a little break here, and I'll come back in a sec. All right, I think I can struggle through this. Just a little break there. So you need to know that this is your natural break in the question, and I am not going to try to factor yet because I've got some monomials going on here. So I've got this one with this one, which means in the front half before the plus sign, I'll have 8x, and then x squared plus 3 cubed, and then 2x plus 3 squared. And then I don't have any negatives back here, so I've got a plus sign, and I get to repeat it. So for instance, here's a monomial and here's a monomial. So I can make that 4, and here's my tip of the day. Put this bracket first because it was first here. So I'm going to write x squared plus 3 to the 4, and then in a bracket behind, 2x plus 3 to the 1, and of course I'm going to leave off the 1 because of laziness. And now I can factor, and here's the plus sign that is the dividing line. So I need to factor or compare this with that. So out of 8x and 4, I can take out a 4. I've got x squared plus 3 as a bracket. There's 3 at the front and 4 at the back, so I can take out the minimum number, which is 3. Then I've got a bracket of 2x plus 3, and I've got 2 at the front and 1 at the back, so that means I can take out one of them. Square bracket to leave things behind. So no plus sign, this is times a square bracket. And recompare. So if we took a 4 out of 8x, that's 2x. We took all of these x squared plus 3 brackets. See, there were 3 of them. I grabbed 3. We took 1 out of 2 of those, so I need 2x plus 3 to the 1. Plus sign. Do it again. I took 4 to 4. I don't have to worry about that. I took 3 of these x squared plus 3 brackets out of 4 of them, so I need another one. And I don't need the bracket because I'd be multiplying by 1, so I would need the bracket if something had been left. And I would need the bracket if there were any 2x plus 3 brackets left, but I took them all out so I can end. And this is where I cheat again. So I'm going to multiply this out in green. So 2x times 2x, 2x times 3, 1 times each of these. And I'll have 4 bracket x squared plus 3 cubed, 2x plus 3. So this is all the before the square bracket, and then the square bracket will turn into a round bracket as I collect these like terms. So 4 plus 1 is 5x squared plus 6x plus 3. And technically you should check to see if you can factor this bracket more in case you have brackets that will join with these guys, as in maybe one of them is identical. But I can pretty much look at this and say, yeah, that's not possible to factor. So we are done. Now remember, you are factoring this not for fun, but because we do things with calculus. So calculus lets us do a whole bunch of stuff, and I assume you are here for a reason and not just because calculus is a ton of fun. I am going to make a brand new page and attack this second last question. And just so you know, you should think about this question. Notice this is not blue or green. You should think about this question as in this 2x plus 1 needs a bracket with an exponent 1/2, and then the 3x to the 5 plus 4x all to the 5 can be like that. Now, because it's a fraction there, I am not going to dive into the question and do it all at the same time. I'm going to carve off a little space off to the side to list my stuff and then piece it back in. So your choice as to how you want to attack it. It also depends on how comfortable you are with the previous 2 lessons. So if you've done very little about the derivative rules, which was lesson 1, and very little to do with the power of the function, then you are putting yourself in a position where the product rule, the extended product rule, which is the half lesson that comes after this, and the quotient rule are going to be darn impossible because it's way too much stuff going on in your brain. So attack this as it's delivered, and that is slower than you might like, but hopefully a comfortable pace. So no f at x's in the original, so I'm going to call the first bit f at x, which is the 2x minus 1 to the half. And I'm going to take the derivative of that, which is going to take the last lesson, the power of a function lesson, where you drop the 1/2, you keep writing, you make it 1 less, and then go inside and multiply by the derivative of the 2x plus 1, which is 2. And I've got a monomial here and a monomial there, and a half times 2 is 1. So, hey, I don't even have it there anymore. What a great deal. Second half. G at x is going to be a pain in the butt, even worse than a fraction. So it's 3x to the 5 plus 4x all to the 5. And my g prime at x, the derivative of that, is drop the 5, keep writing, make it 1 less, so that means the exponent is now 4, and then in a bracket behind, the derivative of this. So that's 15x to the 4 plus 4, x to the 0. And I don't have any monomials, but I can stop. And because when I took the derivative of this, it was a 2-piecer, a binomial, as opposed to a 1-piecer, a monomial, that means you have to wrap it in a bracket. So now I'm going back over here. And I'm digging out my blue pen to say, hey, let's take the derivative of the whole thing entirely using the rule. So I think I'm going to run out of room, so I'll show you my solution. So the derivative of the front is this. Times the plain old back is this. And then you realize that when you're going to do the reverse or the second half, it's going to be a mess. So this is like a really good safe hyphenation point. So that's where I'm going to put my plus sign, and then I'm going to drop down. So I advise you not to split either the front half of the rule or the back half of the rule, but split at the plus sign. So now I can write down the derivative of the second, and I have lots of space. Times the original first. Now, the good thing about this question is in the front half there's no monomials to collect, and actually in the back half there's no monomials to collect, so I can go straight to the factoring. And the reason I split it there is now I can compare the before the plus sign stuff there, which is intact, and the after the plus sign stuff here, which is intact. So it's all like in the same line of work. I think I can manage to take the derivative in one line because I have the rest of the page. So between 2x minus 1 to the negative a half and 2x minus 1 to the positive a half, the minimum is the negative a half. So I am going to put that as my first factor. I don't have to worry about a number because there's no number out front before the plus sign. Then I've got 3x to the 5 plus 4x all to the 5. And back here, I've got 3x to the 5 plus 4x, only this one's to the 4. So between 4 of them and 5 of them, I take it the minimum, which is 4. Lay down a square bracket. Recompare. I took out this identical thing, so there's no more left. I took out 4 of the 5, so I have 1 left. And I don't need a bracket because it's one of them right at the very start. Now I put down my plus sign, monstrous or not. I didn't touch this 5, so I need it. I took out every single one of these brackets, so all 4 of them, so I don't need any more. I have 15 x to the 4 plus 4 because there weren't any in the front half, so I definitely have it left behind. And then here's the kicker. The difference between 2x minus 1 to the half and the 2x minus 1 to the negative a half is a whole bracket. Because if I draw you a number line, bad number line, here's 0, here's negative a half, here's positive a half, this space is 1. So also, we subtracted 1 to get it. So that means I need a single bracket of 2x minus 1. That was hideous writing. 2x minus 1 to the 1 and the bracket. So this is what makes taking derivatives awful for me, is we actually have to FOIL this out and collect like terms. Yeah, we have to. I didn't make this rule. This is the rules of calculus. So I'm going to actually pause it and write it all down so I can take my time and get rid of this hand cramp I have. And I'll come back. I'll have all the green stuff because I'm going to illegally do it, and then I'll piece it back together for you. I will talk you through as well. So give me a sec. All right, I did it. So first thing I did was FOILed out these 2 brackets. So 15x to the 4th times 2x is 30x to the 5. 15x to the 4th times negative 1 is negative 15x to the 4th. 4 times 2x is positive 8x. 4 times negative 1 is negative 4, all in a bracket, so I can now multiply through my 5, and I didn't forget to write this down again. Then I wrote it down again, and I multiplied the 5 through, so 5 times 30 is 150, keep the x to the 5. 5 times negative 15 is negative 75, keep the x to the 4. 5 times 8 is 40, keep the x. 5 times negative 4 is negative 20, no x's at all. And then I collected like terms. So here are my x to the 5's collected. Here's the x to the 4. Here's the x to the 1's collected. And here's the number. So now I'm going to write all this down. But I want one less line, and I'm going to talk you through this. So I do have a bracket. Wrong color. I do have a bracket. What the heck? I do have a bracket of 153x to the 5 minus 75x to the 4 plus 44x minus 20. I also have a bracket of 3x to the 5 plus 4x all to the exponent 4. And I also have this bracket, which I can put down here if I want. But I notice it's got a negative exponent. Wow, my handwriting's getting worse. And on top of that, it's a negative fractional exponent, and a half came from a root. So I'm going to put the 2x minus 1 downstairs for the negative and put it back to a root, which is what it was originally, and that's how I got the half. So this is a very textbooky answer. It's kind of what you're heading towards, so we can do more math with this. Because you do not take the derivative, whether it's derivative straight up rules, or whether it's the power of a function rule, or whether it's the hideous product rule, which requires you to do a whole bunch of math. You don't do this for fun, you do it for a purpose. It's why you're taking this course. So this is the end result of the derivative, and then you do stuff with it after you hopefully practice enough of these rules all by yourself. Or with my help. Remember, you can always ask for help. So here is one of the purposes. It's not quite a word problem, but it's not a word problem. So the exciting part of this question for you is that there is no brackets. But oh my gosh, it's a quotient. It's a fraction. It's not even a product. So what do we do with that? So the first thing I do want to tell you is that I haven't read the question and I know I'm going to have to take the derivative because that's calculus. So let's pretend like there isn't all these words. And this is a safe way to proceed so you have a starting spot on your questions. So the first thing I'm going to do is show you how to take this quotient and turn it into a product so you can use the product rule. Because we haven't dealt with the quotient rule. It's like a lesson and a half from now. So this is still y. I'm going to put x to the 5 minus 3x to the 2, no exponent, but in a bracket. And then I'm going to bring the whole 2x upstairs, and I am going to make it to the negative 1, because down here it's to the 1. And now I can keep going. So I'm going to do my scribbles here. My f at x is equal to x to the 5 minus 3x squared. And I need to take the derivative of that to do the product rule. So 4, scratch that. Drop the 5, make it 1 less. Drop the 2, multiply, make it 1 less. G at x is equal to 2x in a bracket to the negative 1. And this requires the power of a function rule. So drop the negative 1, make it 1 less, go inside, take the derivative, and then if you want to, you can clean it up here rather than over on the left where I'm going to piece everything together. So now, blue pen, y prime. Haven't even read the question yet, but y prime. Derivative of the front times the plain old back plus sign for product rule. Derivative of the back. Oh, that's all right. Times the front. Right here. And unfortunately, I have to do some I don't have to do any cleaning up. This is not a monomial because it's got an exponent. And the exponent is on a bracket. So now I just get to factor. So red pen, rope off this, and we're comparing it to that. Blue pen. So I've got no other crap. I've got no other 5x to the 4 minus 6x's over here, so I have to leave it. I do have a 2x bracket, negative 1 here, negative 2 here. Between negative 1 and negative 2, your minimum is negative 2. So negative 2 is less than negative 1. Square bracket. I need 5x to the 4 minus 6x, because I didn't take it out, and I took 2 out of negative 1, so I actually have one of them left behind, because they don't match. This plus and this minus is going to make this a minus sign. I need the 2. I took out all of this bracket, and none of these, so I need to lay it down again. And then I'm going to dig out the green pen again, and I'm going to multiply all this out. Notice that the brackets don't have exponents on it. That's pretty typical. So 10x to the 5 minus 12x to the 2, this times this, minus 2x to the 5. Oh, water alarm. I don't have my water. I'll finish it after this question. Plus, because it's a negative times a negative, 6x squared. And then I'm going to write down this in blue because I'll have collected. So that's 8x to the 5, 10x to the 5 minus 2x to the 5, minus 6x to the 2, negative 12 plus 6. And then I've got this thing, which has a negative exponent, thankfully not a fraction, so that means it's not a root. but I can take 2x down to the bottom, and I can use the positive version. And that's my derivative. So you will get a ton of marks for doing that, but let's actually read the question. So it says, determine the point on the curve defined by, so here's our curve, our rational function that you can graph using everything you learned in advanced functions, the vertical asymptote tests, the horizontal asymptote tests, the oblique asymptote, or you could have done the derivative using limits, which would have been worse than this. But it says where the slope is 0. So if this is the slope, messy, messy slope, and 0 is the slope, what I can do is I can actually take x, 8x to the 5, minus 6x to the 2, over 2x in a bracket squared, and I can equal it to the slope, which is 0. Better, 0 over 1, so that I can cross multiply. So this is where calculus goes back to basic math. So if I cross multiply, this way will be 8x to the 5 minus 6x squared times 1, which is 8x to the 5 minus 6x squared, equal sign, cross in the other direction. 0 times I don't care is 0. This is factorable. So I can take out 2x squared and leave behind 4x to the 3 minus 3 equals 0. Then I can dig out my green pen from advanced functions, and I can do 2x squared equals 0, and 4x cubed minus 3 equals 0. Divide this by 2. I get x squared is equal to 0. Even though it doesn't matter, when I take off a 2, I put on a plus minus root sign. Because it's 0, I end up with 0. So backtrack a little bit. Use black pen this time. X equals 0 is an answer for that. Now I'm going to dig out the green pen and do it all here too. So this looks like you could pump it into the quadratic equation, but you can't because it's a 3. So 4x to the 3 equals 3 on the other side. Divide by 4, divide by 4. So x cubed is equal to 3 over 4. And x will equal the cube root of 3 over 4. So if you want to use a decimal, you could use a decimal. If you wanted to use this, that's fine. I will use a decimal in a moment. You do not need a plus minus sign when you're using an odd number. You only need a plus minus sign when you have an even number and you're rooting. So let's go back and see what the question asks, because I will need the y's if it wants the points. Crap, I need the point. So I need to go back and I need this thing. So I'm going to just scribble it down for a second. So y equals x to the 5 minus 3x squared over 2x. So that's my y. So I will be able to generate x's based on that. Sorry, I'll be able to generate y's based on these x's. So I'm going to split my page. So the first thing I'm going to do is I'm going to take this put it here, and put the y value in there. Sorry, x value in there. So 0 to the 5 minus 3 times 0 to the 2 over 2 times 0. Oh, bad math. There is no solution for this, so there's no point for that. And I don't mean no point, I mean no actual point on a grid. So I need to take out my calculator to figure out what that hideous decimal is. So this is not necessarily a question you would get going to a school that doesn't let you use a calculator. But I have to do 3 divided by 4 equals, and then I need the cube root, so I don't know if I have that button. Where would it be? Oh, I do have a cube root button. So I'm going to use 4 decimal places, so 9086. And I'm going to put that in here. So y equals 9086 to the 5 minus 3 times 0.9086 to the 2 over 2 times 0.9086. Oh, I think I'm going to sneeze. Hold on. Oh, I got it under control. Maybe not. Oh, gonna pause. All right. Whew. So I don't know how to use my memory button on this thing. Some of you probably do know how to use your memory button, so I'm going to be super inaccurate here. So 0.9086, that's my inaccuracy. Cubed. Oh, shoot, I think I screwed that up. 0.9086 cubed minus 3 times 0.9086 equals, so my numerator is, oh, I'm going to write that down, negative 1.9757. Forgot it already. 757. Two times 0.9086 equals 1.8172. 8172. And then divide. Super inaccurate because every time I clear this out and round, I'm creating inaccuracies. Negative 1.09. Let's go 2 decimal places. Negative 1.09. All right, so read the question again. Got to read it a number of times because there's so much going on here. So determine the point. So it was really smart that this question maker, not necessarily me, knew that it was only 1 point, even though we came out with 2 x values. Determine the point on the curve divided by this, where the slope is 0. So the point the slope is 0 at the cube root of 3 over 4, or 0.9086, comma, that. So if you graphed this rational function and found out where the slope was 0, the point that would be happening would be a terrible number, but it still happens. So there's the product rule. For no reason. For no reason again. For no reason. For no reason. For no reason other than to practice the skills so that when I give you a question, that is something you're able to do because you've practiced the skills. This goes on forever. So here's the stuff in your textbook. I'm not sure why it's out of order. I actually think that these are more complicated questions. That would be my guess, meaning those are questions that have exponents on brackets. And then the second set, which is previous in the textbook, would be questions like this, which still have brackets or terms in brackets and don't have exponents on them. So I think that that's probably what I was thinking. So you can read this if you like and sort it out. I'm going to come back with the extended product rule. Yikes. Oh, wrong button.